So now we are recording, and the next speaker is from the Agricultural University of Iceland, and he's also the pioneer of mapping the Icelandic depth sources. So I will listen to yeah, and you have to move it here because the pointer is not working. Welcome, Olafur.
Thank you, Pavla. Thanks for a great talk. It's hard to come after that. You show so much data and so much modeling, and I'm not a modeling person. I'm a ground person, very well grounded generally. A field person in geology and geomorphology and soils, etc. I'm really, it's really impressive how these meetings have evolved. They are bringing people together, and so it's so nice to see. You know, I will be in touch with you. Can we use your equipment and getting new groups together or cooperation? So, yeah, Pavla, you're doing great, Roti. It's just nice. I started in this business a very, very long time ago, and I quit working. I'm retired, but I'm a soil scientist and educated in USA. And I worked with wind tunnels in Big Spring and so forth long time ago when we were developing wind erosion equations. I was fortunate enough to do a project of mapping soil erosion in Iceland, which is a huge problem. And we had to design a system for it. We spent 6-7 summers in the field. It was a relatively big group at the time, lots of money involved. But we were quite successful in building databases that have been used very extensively by others. It's part of the weather prediction models for Iceland. For example, a lot of the ground data comes from our data. And it comes to a surprise, but not to the people here, that Iceland has so many barren areas. And it's, you can argue, are they deserts or not? That's, you know, it depends on what you use as to define deserts. But 40% of Iceland is relatively barren. And that is a lot in a subarctic area, which should be more or less totally fully vegetated. There are a lot of reasons for this, some natural, some anthropogenic, unfortunately. And we had to develop a system to characterize the desert surfaces when we were doing the erosion mapping. So we have a classification system for different barren areas. And it's the type and also the severity of eolian processes. So we have the pure sandy surfaces, but we have also the glacial till, old glacial till surfaces that have been receiving a lot of eolian materials, and we call them sandy like gravel surfaces, and they become active under high wind speeds, but the sandy surfaces here, you only need 7-8 meters per second, and you have a sandstorm and dust. Then we have the lag gravel, which always have some sand in it, but it takes like 20-25 meters per second to start moving this stuff. And you see here, artifact here. And then, of course, it's a volcanic island. There are a lot of lavas, and they are close to sand sources. And the lavas, if they are very rough, they act as a trap for sand. So the sand is moving with the dry winds, slowly filling up the lava surfaces, and in the end, they become sandy surfaces. And they are active for sand. But, you know, how much dust is coming from each area, that varies a lot. So this is an overall map with the sandy surfaces, and the red ones are the most active, which we categorize as erosion class 5. And these are where we have high intensity sandstorms occurring, but not all of these are producing a lot of dust. That's the major dust sources we have identified are the green dots here. They are hyperactive dust sources, and we need to understand these areas to understand how much dust Iceland is producing. It's amazing. But when the wind is blowing at 30, 40 meters per second, you know, all of these red areas here and pink areas, they become active too. And also, as you know, we have the Atlantic Rift goes into Iceland here and continues up here. The hotspot is approximately under this part of the country. There are over 30 volcanic systems in Iceland. And this is one here. This is what is active now, and it's probably 3 systems now. And hopefully you will have a volcanic eruption tonight to enjoy, but I can't guarantee it. There's probably some weeks, 1 week or 2. But this is all basalt. And when we have eruptions under the glaciers, we have a lot of volcanic gas production. And then these glaciers are capping volcanoes that have been erupting, producing palgrite and loosely attached. It's not solid rock that these glaciers are on top of. So the sediment load of the glacial rivers coming out of these is huge. And the rainfall here per year is 3,000 millimeters per year. Iceland is the landmass of sizable landmass that has the highest runoff in the world. There's so much precipitation falling on this island. Enough about the geology, but after being mapping and being traveling in Iceland for a lot of decades, I decided in 2010 to work a paper on how much dust deposition there is in the country. This was the result. This was before the Eyjafjallajökull eruption, and nobody in Iceland was thinking about dust. And this was a total surprise. This was published in an obscure journal, the Agricultural Sciences of Iceland. And 3 years later, it was the highest cited agricultural journal. It was a Q1, it's obscure just because of the dust. I had no idea there was so much interest in dust. So we put Iceland on the map, literally speaking with this. And then, of course, there have been some talks among us about lichens and mosses and heavy metals and so forth. We don't have these problems in Iceland, except there is a lot of iron, 10% iron in the dust, and it accumulates in the mosses, and you see it's almost exactly the same map. People really didn't believe at first in this map here, but I think people are more or less okay with it by now. And since we have such a high level of dust protection, and this is volcanic glass, and it produces or makes soils, so soils develop. It's extremely rapid chemical weathering in these materials. And these soils have nothing in common with the soils of like Greenland or on the continental shields or granites and so forth. These are andosols, volcanic soils. They're extremely reactive. The clays in them are like alpine and ferrihydrite. You know, these are not the common clays like you go to Denmark with smectites and so forth. It's very, very different. And there's a lot. I mean, the surface is just steadily rising all over the country where there is vegetation. The deserts are a little bit different. So anyways, so we improved the map. I was asked to, modify it for other uses. A lot of people have used this modified map for modeling of all sorts of other things. And a strange thing is that, which are not strange, you know that birds, they are at the top of the food chain. And there is a lot of data on birds in Iceland. So, and birds, they kind of indicate the status of ecosystems and so forth. We mostly hate dust because of what it does to climate and what it does to human health and so forth. But dust is beneficial to ecosystem. So this is what keeps Icelandic soils very fertile, really fertile systems. And the birds, they actually, the highest density of birds are found in vegetated areas with a lot of dust. This is the opposite what to most people would think it was, but the dust is weathers very rapidly, it maintains high pH and so forth. So it's quite interesting. And I don't think data sets like this exist elsewhere, but we have more of this kind in Iceland. And then we try to quantify, I like all of these models and so forth, but what I want is how much, it's just, I don't know, old fashioned, I guess, but we found out that the dust production in Iceland, our best estimate, is somewhere between 30 and 40 million tons per year. And this is a lot for such a small island. And the models, when they started using them to backtrack and model, they come up with much lower numbers until these guys came along, Ojan and Likovic and all of these people. We altered the models. We changed the parameters of the models, and then it's starting to fit quite well. And it takes, because we needed to take the hotspots into consideration. And I wanted to show you a little bit about this hotspots and it's really hard usually to change when you learn something in school, and people were told me in school, everybody, that the dust is coming from these kind of processes, soil erosion. So it's soil being blown over the country. And I was always wondering, okay, where is all this soil coming from? Of course, they were totally wrong. It's not soil. It's coming from the desert. But these are staggering, of course, pictures. But they were right during the Middle Ages. We had way too many animals on the land, mainly sheep. There was a huge collapse of Icelandic ecosystems, and they are noted in books like from Jared Diamonds and so forth. And soils were the main source of dust during the Middle Ages, and I mean like 14th, 15th, 16th, 17th century into the 18th century. But now it's the dust hotspots and deserts. And why did it change? It's because we lost all our, the soil is gone from a lot of these areas. This used to be a birch forest. It's a total desert now. The soils are gone. And after 1920, the glacier were expanding till about 1920, and they have been retreating, creating these hotspots more, bigger. And especially after 1990. And also, they killed all of the pioneer species like birds and so forth. They just disappeared from the species composition around the areas where we have flooding in rivers and so forth. So these areas remain barren. The vegetation comes and invades it. It doesn't come back because we keep it down by subsidized grazing in Iceland. And of course, a lot of these also are formed during volcanic eruptions and the glacier and so forth. So it's a complicated picture or not. To me, it's not. But we will see more dust in Iceland in the future. Just to give an example, this is present day in around a glacier river in North Iceland. But they used to cut the wood here to work on iron. They leaned a lot of wood to heat up the iron source, which comes from the soil. But this is probably what it looked like in 13th, 14th century. There is everything you look at in Iceland, it's beautiful landscape, etc., but it's disturbed to extreme level. We used to have 25, 30% birch forests. They're just gone. There is 1% left. And then the crazy tree people come in with introduced species and invasive species to correct them. That's another story. I'm an environmental activist in part, because I think we should be people that know. So coming back to the hotspots, the black spots now on this, give you some examples of this. Dyngjusandur is the biggest one. And here's one minor episode, wind blowing from the west, leaving, and I happen to be 120 kilometers away from this, camping out, and this is what the valley and 120 kilometers away from looked like that day. So we started to think, oh, this is a lot. And with all these satellite images, we sort of put the picture together. And the Hagavatn dust hotspot, I mean, this is quite impressive. And this is the south coast and other areas. And this, but you know all of this, of course. And the Dyngjusandur hotspot, here we have like 5 meters per second wind. And it's already started giving these dust balls. This is north of Mýrdalsjökull in central Iceland. It's a good example. You see the rivers coming out, they're full of sediments, but they disappear. And they don't, yeah. It's so porous. So all the sediments are left, of course, on the surface. So these become hyperactive dust sources, the dust hotspots in Iceland. But there are more types like the beaches and so forth. This is what it looks like on the surface. And a little bit further down, all the water is gone. It seeps into, comes out as a spring water, very pure and nice, maybe 50 kilometers away. This is a Hagavatn dust hotspot and very nice weather. But these are sediments. It used to be a lake all the way up here. And then the glacier changed and the water level dropped by 20, 30 meters. And it doesn't take much wind to get this start to blow. And this is what it looks like on the surface. This is pure silt. I mean, glaciers are the main producers of silt in the world. That's what they do. They produce silt. And this is on active day. And you all seen pictures like this, but yeah, this is fascinating, actually. And this is another source there, and there is a sand river there, 16 kilometers long. And this is taken 30 kilometers away another day, and really long. And this comes over Reykjavik periodically, this dust. And now to Dyngjusandur. Pavla and I, we love Dyngjusandur. This is the biggest spot north of Vatnajökull glacier. And of course, this nice caldera here, Askja. And there are the glacier rivers. This is really the main dust source. But the wind continues carrying all these materials further. to create a sand sheet downwind. And it's very unlike really the main dust source. And then the wind continues, and if there is a mountain or something, sand accumulates there. And water is very effective bringing the sand back to the sheet, so it blows up, and then there is a rainy season or snow melt, then it's brought back. And here we have a river of sand, and they can be 10, 20, up to 80 kilometers long. But the dust goes from this dust hotspot in all directions, northerly directions, northwest to even southeast. And further up there, another sand river. And so it's a fascinating geomorphic landscape. A lot of things that need to be done there. So this is what the main dust source looks like, and this is from the field campaign in 2022 here on the right. So it's a drone image, and it's only part of the source, and it's a hyperactive source. This is a sand sheet downwind from the main dust source. And there is accumulation areas like this, and I really would like to know how much sand has been accumulating there over the past decades, and it's probably in hundreds of millions of tons. This is 80 kilometers further downwind during a very windy day, and there is almost no dust at all. It's all saltation. The dust has been removed, the small grain size, but saltation is hitting us up to about here. There's no problem standing there, but you can feel it up to about me. And the beaches are, of course, when the glacier rivers hit the ocean, a lot of these finer sediments, silty, are brought up to land, to the beaches, and then they become extremely unstable. And you can have days like this where from the shore of Iceland with huge dust storms. And they don't measure anywhere. Yeah, you don't see this on land. You only see it on the satellites. And the glacial rivers from flooding, you have the same thing going on there. And in addition, some of these volcanic eruptions create temporarily a lot of fine sediments. What I would like to emphasize that this is full of iron and actually high in titanium and other materials. So it's very different from the both calcareous or the quartz dominated dust that you find elsewhere. So it's basaltic and very fertile. And it's bad stuff because the lungs have problems dealing with this, and we are ignoring this as a nation, as a health problem. So in conclusion, it's very hyperactive country with 30, 40 million tons per year. And it's a unique composition. It's volcanic glass, very reactive, weathers rapidly, both on land and sea. And it's probably affecting the fertility of the oceans around Iceland and the fisheries. We need more research on that. We are ignoring the health effects too much. But this is also what makes Icelandic nature, because it modifies all ecosystems on land. And I would like to add, because of the modeling in the last presentation, for CO2 emissions in Iceland, the big smelters and transportation are not the biggest ones. It's the land. It's the degraded heathlands and drained wetlands that give off probably 13 million tons per year, while everything else is about 4 million tons. But the government and the public and the NGOs, they're all obsessed with these 4. We don't like to talk about the land. But that's another story and another presentation. But I'll stop here. Thank you.
very much, Oli, for this really great presentation about the sources, which are really complicated. Are there any questions here in the room for Oli? Can you please pass the microphone to Alexander?
Yes. Thank you. It's very interesting to see the difference between different areas and, of course, mechanisms. Just my question is about kind of recultivation or some also measures to reduce such dust in car produced here for green grass growing or something.
Well,
what kind of methods are suitable and use it here?
We have an institution formed by the Danes in 1907. It's the oldest soil conservation service in the world, probably. We're trying to stop the degradation, but we're not dealing that much with dust per se, but stopping the sand, the advancement of sand. And it has been stopped most of the time. Dust is tricky in the highlands and so forth. And actually, I think it should be protected to some areas, you know. It's a natural process, like in Dingy Center, it's not causing that many problems. But in the Reykjavik area and the dust source closest to Reykjavik area should be addressed probably. But these quick solutions that are always being suggested, drowning it and have a hydrothermal, a power station, you know, a reservoir, I'm really have to put a lot of effort stopping all those kind of ideas, because it's basically rich people who want to get more rich. They're not really thinking about nature. Some of these sources, we just had to let the dust go. It will, if it's a source from a lake bed, it will eventually be depleted.
Pavla, this is Nichko.
Yes, Nichko, welcome. Hi.
Hello to everybody. For my greetings, we didn't talk for a while. And I would like to comment a few things that you have presented. First, this is impressive evidence what you showed related dust in Iceland. And connected today, I have to say that from the very beginning, at the time we decided in Belgrade to develop this Iceland dust model, the key input was coming from Olafur. All the maps, necessary maps concerning the sources and a few other information was key to start up everything. So I was really happy to have you together with Pavel, of course, in the group and contributing. My specific question today is you have shown a map with the iron content over the island. And this is one of the things that this is on our to-do list, but we don't have enough time for everything. But anyway, there is in general plan that we incorporate the iron component in the soil from Iceland. And for that would be very important that we don't have only gridded data on iron content, but also on potential solubility. Probably many of you know that once iron travels together with the dust or in dust, better to say, after depositing into the ocean, reaction of the ocean habitat is much stronger if there is already some soluble component of the iron. So my question is, do we have from your side gridded data on iron content? That's one thing. And in addition to that, could we also estimate the potential solubility in every research point?
Yeah. The iron content is very simple in a way, because all of these systems from the hotspot, Dingy Center and around it's 10% iron, more or less. You know, that's close enough.
Okay.
But the solubility, especially in the ocean, is a different, and you see the numbers go, there have been experiments with it, but some of it is actually made available, definitely, but we need a lot more research from the oceanographers. They have been very slow to pick up on this, mainly Germans that have been studying this. Solubility in the soil is another story, and it's quite rapid. It forms special mineral, ferrihydrate. It's really small, really reactive with surface area per gram, maybe 500 square meters. So it's one of the things that makes these soils very fertile. And water retention in the soil is way up, but also landslides.
Thank you, Oli. I have
Okay, thank you.
because we need to take a short break now. So
Okay.
feel free to write the messages in the chat and Oli can answer afterwards
Yeah.
or anyway, thank you very much for this initial session. And we'll have 5 minutes break and start again at 11 PM. Yeah, so really quick.